The James Webb Space Telescope has made another groundbreaking discovery, uncovering a galaxy so ancient that it's beginning to change our understanding of the cosmos. To fully appreciate the significance of this find, we need to rewind, not all the way to the dawn of time, but back to 2022. Before 2022, the most distant galaxy ever observed was GNZ 11, identified by the Hubble Space Telescope. This was a milestone achievement, as Hubble's 2.4-meter mirror and advanced optics had taken us incredibly far into space, but there was a limit to how deep it could see. Then came the James Webb Space Telescope, equipped with a much larger, 6.5-meter mirror and designed to detect infrared light, the stretched and ancient light emitted by the earliest galaxies. JWST didn't just continue Hubble's legacy, it shattered all previous records. In one of its early missions, it discovered a galaxy called JD's GS Z14. This galaxy set a new record for the most distant confirmed galaxy, showing a redshift. A 1432 redshift essentially measures how much the light from a galaxy has been stretched due to the universe's expansion. The higher the redshift, the older the light we are seeing. Shortly after, another galaxy called MOM Z14 was found, pushing the record even further with a redshift of 14.44, allowing us to peer deeper into the early universe than ever before. But what really amazed scientists wasn't just the redshift, but the actual characteristics of this tiny galaxy. At only about 500 light-years wide, especially small compared to our Milky Way's massive 100,000 light-year span, MOM Z14 is remarkably bright. Normally, galaxies from this early era are faint and hard to spot, but MOM Z14 is bursting with newborn stars acting like a rapid-fire stellar nursery in the universe's infancy. What made MOM Z14 even more puzzling was the absence of a supermassive black hole at its center. Most galaxies with intense star formation have these giant black holes, which play a crucial role in regulating star birth, shaping galaxy structure, and driving growth. Yet, MOM Z14 lacks this feature. The mysteries don't end there. When astronomers analyzed the light from MOM Z14 using JWST's spectrograph, they found it unusually rich in nitrogen. This chemical signature resembles what we see in some of the oldest star clusters orbiting the Milky Way, suggesting that MOM Z14 is forming stars in extremely dense environments. This is unexpected because early galaxies were thought to be chemically simple, mostly composed of hydrogen and helium. Instead, MOM Z14 shows evidence that multiple generations of stars had already formed and died before it, implying that galaxy evolution began much earlier than previously believed. This raises the question, how many more galaxies like MOM Z14 are out there? Before JWST, scientists assumed such ancient galaxies were extremely rare, but now, more are appearing across JWST's surveys. These bright ancient galaxies, sometimes called little red dots, are much more common than expected. MOM Z14 might hold the current record, but it's likely that new discoveries will soon surpass it. The more we explore, the more we realize that our assumptions about the early universe need revising. If galaxies like MOM Z14 existed in greater numbers, formed stars faster, and were chemically richer than we imagined, then what else might we be missing? This galaxy challenges our cosmological models. Current theories predict that early galaxies should be rare, slow-growing, and chemically simple. MOM Z14 is none of those. It's fast-growing, bright, and chemically complex. This doesn't mean our models are wrong, but rather incomplete. MOM Z14 offers a glimpse into a more dynamic early universe than we previously thought. And this is just the beginning. Later in the decade, the Nancy Grace Roman Space Telescope will join JWST, surveying larger areas of the sky in stunning detail. Together, these telescopes could uncover hundreds or even thousands of galaxies like MOM Z14, each one a time capsule revealing new secrets about the infancy of the cosmos. For now, MOM Z14 stands as a landmark discovery, a faint beacon from a time when the universe was still finding its footing. Yet as we delve deeper into JWST's findings, the universe continues to surprise us. Some scientists have even proposed bold ideas based on recent data, including the possibility that our entire universe might exist inside a black hole. This idea comes from an unexpected observation. The majority of galaxies appear to rotate in the same direction. By studying the shapes and curves of galaxy arms, astronomers can determine their spin direction. In a truly random universe, these rotations should be split fairly evenly between clockwise and counterclockwise. The fact that they aren't suggests something unusual is happening, something that challenges our current cosmological models. This has led some researchers to explore the concept of black hole cosmology, or Schwarzschild cosmology, which proposes that our observable universe could actually be the interior of a black hole existing within a larger parent universe. To understand this, it helps to look at the physics of black holes. When matter collapses under gravity, it forms a black hole surrounded by an event horizon, a boundary beyond which nothing, not even light, can escape. While the outside view is clear, what happens inside the event horizon remains a mystery. According to black hole cosmology, the Big Bang may not have been an explosion in empty space, but rather the moment when matter collapsed into a black hole, creating a new universe inside it. This theory has fascinating implications. It suggests that every black hole in our universe could be a doorway to another baby universe. It might also explain why the fundamental constants of nature appear so finely tuned for life. Stable universes created by black holes could be more likely to persist and reproduce, leading to a cosmic cycle of universe generation. Additionally, black holes have immense entropy, reflecting the vast amount of information contained in our universe. Some extended theories of general relativity, like Einstein-Cartan theory, introduce torsion, a property related to the intrinsic spin of particles that affects spacetime curvature. This torsion could create a repulsive force at extremely high densities, potentially preventing singularities from forming inside black holes. Instead of collapsing into a single point, a black hole might undergo a big bounce, where the core rebounds and expands, giving rise to a new universe inside. Scientists speculate that this rapid rebound could be what caused our universe's expansion, an event we call the Big Bang. Rather than a singularity suddenly exploding, the Big Bang might have been a rebirth originating from the core of a black hole in a larger parent universe. If true, this would dramatically reshape our understanding of cosmic origins, suggesting the universe is part of an ongoing self-replicating cycle. Another intriguing possibility is that the universe has a preferred axis. Observations of large-scale cosmic structures indicate certain alignments in the distribution and motion of galaxies, contradicting the long-held assumption that the universe is isotropic and homogeneous on large scales. This cosmic anisotropy could point to unknown physics related to how our universe formed, or how fundamental forces behave on the grandest scales. The existence of massive ancient galaxies shortly after the Big Bang challenges our ideas about cosmic evolution. While the black hole universe theory is fascinating, there could be simpler explanations, such as errors in earlier measurements, including how fast the Milky Way rotates. No matter the cause, the universe continues to reveal itself as far stranger and more complex than we ever imagined. The uneven rotation of galaxies alone is prompting astrophysicists to reconsider many aspects of our cosmic understanding. What do you think about these discoveries and theories? Feel free to share your thoughts